Before we consider the other variants that we need to add to our continuation data type, let's see how our variants for handling addition play out. So here's our current interpreter, our lambda interpreter. It takes an expression and an environment to produce a value. And in the plus e case, it works by using num plus on the result of these two recursive calls. This, of course, uses Shplait's implementation of continuations to come back after implementing this interp. So we're going to take more control, and we know that that interp is what needs to happen first, and everything else belongs in our continuation of the mode program. So this continuation in mode terms represents we're working on the left-hand side, the right-hand side is waiting. In Shplait terms of the expressions that need to be evaluated, it's exactly what we had written there, right? So this is the same idea. We need to get a value back, then we need to interpret the right, then we need to add it together. But as we've said, the way we can represent that with our continuation data type is using a plus second k. So plus second k needs the expression to evaluate and the environment where it should be evaluated. And notice how those are the non-constant parts of the code that we used to have here. It's always num plus and it's always interp, but r and the environment change, and so that's why we put those in the continuation. But there's a piece missing in this continuation. Plus second k actually takes three parts: the right-hand side expression and its environment, and the rest of the continuation. That is, once we perform this addition, where do we deliver the result? What do we have to do after that? So to get to the right argument here, we need it to be passed into interp. Interp is going to take three arguments: an expression, an environment, where that expression is interpreted, and a continuation, which is how do you continue after this interp would be done. And k then means this is how you continue after you get the result of a plus, so that's why it becomes the argument to the last argument to plus second k. And then when we have this call to interp right here, now we are missing a third argument to that interp. The third argument should be what to do next when you get the result of the left-hand side expression. But that is, of course, exactly what plus second k is, so we pass it along as the third argument there. So this is the full implementation of plus e now in our new interpreter. When you start adding left and right, then you start interpreting, and you remember that after you get a value back from the left, you need to go do something with the right and actually add them together, and then continue on further. Where that further work is whatever we need to do after we add these two numbers. That is, whatever continuation was supplied when we started interpreting the plus expression. So if we keep calling interp like this and we keep just making the continuation bigger, where does it ever end? To see that, we can consider the integer case, because when we have an integer expression, we can immediately produce an integer value. We used to just return this integer value, but when we returned it, then Shplait's continuation would know what to do with it. Now we are explicitly representing in k what we should do after we get a value back. And so we need to somehow combine that continuation with this value to continue. This time it does work to have a helper function continue. And it works because there are no new interps that we are introducing here. We have a value, we have a continuation. We can then do the next step on that continuation. The continue function then is always going to take a continuation and a value, and it's finally going to produce the end value of the program. It's going to do everything that's on that to-do list in that continuation, give you a value back, and then that's the value that interp will return back, and so on. How do we continue? Well, our continuation is a new data type that has different variants. For example, it has a done k variant. The done k variant means there's no more work to do, so in that case we really can just return a value. But the more interesting case is with a continuation like plus second k. Remember that this continuation represents this piece of our old interpreter. Once we get a value back from the left-hand side, the thing to do is to interpret the right-hand side and then perform the actual plus. That next step, of course, is to interpret the right-hand side. So we see that's what happens in continue for the plus second k case. It starts interpreting the right-hand side. When we do that, we need to supply a continuation to that call to interp. And what we need to put here is we don't need to remember the r and m anymore because we'll get a value back. But what goes in place of this dot here? This dot is the value that this continuation was waiting for. That is exactly what was passed to continue as the second argument. So we're going to remember that value v there while moving the dot to the right-hand side because that's the value that we're waiting for now with this interp. And then we will actually be able to perform the plus. So remembering to perform the actual plus, that is the job of the do plus k variant of our continuation data type. And then don't forget about all the things that might need to happen after performing the addition. All those things that might need to happen that was represented before by next k, and so it's still the same dots, the same thing that needs to happen after we perform the final plus. So this is the complete implementation of the plus second k of the continuation function. Start interpreting a new right-hand side, remembering that we need to do the plus and then everything else that's supposed to happen after that. The do plus k case, remember, as we just used it, that corresponds to calling num plus. We have one value, we're waiting for a second value. That first value now we've renamed to v underscore l, because v stands for the value delivered to this continuation, that is the value that goes into this dot, that is the second argument to num plus. So at this point, we don't have to call interp anymore. We can actually add the numbers up, v, l, and v. That will give us a value back. Again, we used to just return the value, but we never just return values anymore. We pass them on to continue with the rest of our to-do list here, which is represented by next k in our do plus k record.